All right, so I think let us start. Welcome to this second Wednesday lecture of खगोल मंडळ. मंडळी तुम्हा सगळ्यांचं स्वागत आजच्या ह्या दुसऱ्या टॉक मध्ये खगोल मंडळच्या. खगोल मंडळाविषयी मी थोडंसं सांगणार आहे आणि त्यानंतर आशीर्वाद टिल्लू आज आपले जे स्पीकर आहेत त्यांच्याविषयी सांगणार आहे. सो दिस टॉक इज गोइंग टू बी इन बायलिंग्वल. सो मी पहिल्यांदा मराठीत सांगतो आणि नंतर इंग्लिश मध्ये सांगतो. सो खगोल मंडळ ही आमची संस्था गेले 36 वर्ष काम करते. आमचा मुख्य उद्देश खगोलीय ज्ञान जास्तीत जास्त मंडळींपर्यंत प्रस्तुत करणं असा आहे आणि त्या दृष्टीने आम्ही अनेक कार्यक्रम करतो. आम्ही मान्सून म्हणजे पावसाळा नसेल अशा वेळेला अमावास्येच्या जवळपासच्या विकेंडला स्काय शो करतो. त्याला आम्हाला खूप उत्तम प्रतिसाद मिळतो. त्यानंतर दुसरं म्हणजे आम्ही दर बुधवारी साधना विद्यालयामध्ये संध्याकाळी साधारणतः 7-7:30 जमतो आणि त्यावेळेला खूप अनस्ट्रक्चर्ड पण खूपच उद्बोधक अशी चर्चा होते. आणि सध्या कोविड असल्यामुळे आणि सायनला भेटणं जरा कठीण असल्यामुळे आपण हा नवीन प्रयोग सुरू केलेला आहे. बुधवारची लेक्चर्स. तर आज त्यातलं दुसरं पुष्प आशीर्वाद टिल्लू गुंफणार आहेत. आमचे दुसरे कार्यक्रम म्हणजे आम्ही वेगवेगळ्या प्रकारचे कोर्सेस करतो, शाळांकरता, कॉलेजेस करता आणि काही असे निश म्हणता येईल असे पण आम्ही काही कोर्सेस करतो. उदाहरणार्थ या रविवारपासूनच आम्ही ॲस्ट्रोफोटोग्राफीवरती कोर्स सुरू करणार आहोत. त्याच्याविषयी फेसबुक मध्ये आम्ही ऑलरेडी पोस्ट केलेलं आहे. तर या कोणाला त्याच्या या ॲस्ट्रोफोटोग्राफीमध्ये विशेषतः रस असेल त्यांनी जरूर याचा लाभ घ्यावा. तर हे थोडंसं खगोल मंडळाविषयी आणि आमची अर्थातच संकेतस्थळ वेबसाईट खगोलमंडळ.com. त्याच्यावरती आमचे सगळे काय कार्यक्रम आहेत, नंतर आमच्याशी संपर्क कसा साधायचा, बुधवारी आम्ही कुठे भेटतो हे सगळं तुम्हाला तिथे अर्थातच सापडेल. नाही तर तुम्ही आम्हाला कोणालाही कॉन्टॅक्ट करू शकता. आमचा मानस असा आहे की काही दिवसात, काही बुधवार नंतर कोविड नंबर अजून खाली गेल्यानंतर बहुधा आम्ही संमिश्र म्हणजे हायब्रिड मॉडेल सुरू करू, जिथे आम्ही सायन्सला पण असू आणि झूम वरती पण असू. आणि आम्ही अर्थातच आपल्याला वेळोवेळी त्याविषयी फेसबुक आणि आमच्या दुसऱ्या सोशल मीडिया चॅनल्सवरून माहिती देतच आहोत. आशीर्वाद टिल्लू विषयी सांगायचं तर शिक्षणाने ते एक IIT पवईचे 1982 सालचे इलेक्ट्रिकल इंजिनिअरिंग मधले बीटेक आहेत आणि 1984 साली त्यांनी IIT बॉम्बे IIT पवई मधूनच कम्प्युटर सायन्स मध्ये एमटेक केलेलं आहे. ते व्यवसायाने अर्थातच सॉफ्टवेअर प्रोफेशनल आहेत. ॲस्ट्रॉनॉमी किंवा ॲमॅच्युअर ॲस्ट्रॉनॉमी ह्याचा नाच त्यांना लहानपणापासून होता. त्यामुळे त्यांनी लहानपणापासून दुर्बिणी तयार करण्यापासून अनेक खटाटोप केलेले आहेत. आणि हा त्यांचा छंद किंवा मी म्हणेन पॅशन त्यांनी आतापर्यंत जोपासलेली आहे आणि ते खूपच नाणावलेले ॲमॅच्युअर ॲस्ट्रॉनॉमर आहेत. त्यांच्याकडनं आज आपल्याला खूप काही शिकायचंय. 4-5 वर्षापूर्वी त्यांनी 18 इंच व्यासाची एक दुर्बीण घेतली आहे आणि मी नेहमी विनोदाने म्हणतो की त्यांनी दुर्बिणीच्या सभोवताली एका डार्क प्लेस मध्ये घर बांधलेलं आहे. घर बांधून दुर्बीण न घेता दुर्बिणीच्या अनुषंगाने घर बांधलेलं आहे. तर अर्थातच मी थोडासा सस्पेन्स ठेवणार आहे आणि आशीर्वादना त्याच्याविषयी मग पुढे बोलण्याकरता म्हणजे आपल्याला सस्पेन्स ठेवल्यामुळे आपल्याला अजून मजा येईल. खगोल मंडळ is an institution that was started about 36 years back, and we are essentially devoted to spreading astronomy and through that science to the general public. And for that we conduct many programs beyond the monsoon months, when the weather is not cloudy and the skies are clear. We organize sky shows. That's a very popular program. We get a lot of participation. And if you guys have not attended any of those, I'd definitely recommend you to join one of those programs whenever we start them again. Then every Wednesday we meet at Sadhana Vidyalaya Sayan for a very unstructured discussion, but those discussions are very interesting. And these Wednesday lectures are an extension of those Wednesday meetings. Eventually, once the COVID numbers go down further, we will follow the hybrid model. So we will be at Sayan and we will stream our discussions live on Zoom. And we'll, of course, keep you updated through our social media channels. We also conduct several specialized programs for schools, for colleges. We are also planning to conduct some niche courses. So one of them we're going to start on from this Sunday. This course is going to be on astrophotography. And all the details we have already mentioned on all our social media channels, including Facebook and our own website, khagolmandal.com. So I request all of you to look at those. Now a bit about Ashirwad. So Ashirwad by education is a software, by profession is a software engineer. He has a BTech in EE, electrical engineering from IIT Bombay in 1982, and a master's MTech also in computer science, also from IIT Bombay. But he has been an amateur astronomer right since his childhood. He probably built his first telescope when he might be in 7th or 8th grade, and he's followed his passion throughout. A few years back, he bought a gigantic 18-inch telescope for an amateur astronomer. I think that might be the biggest telescope in this part of the world owned by an amateur astronomer. And he has also built a small facility around that telescope in a dark place. And viewing through that telescope is absolutely fantastic. But failing that, I think we can listen to Ashirwad, because obviously we all cannot go and watch through that telescope. But so we organized this lecture today so that we can hear from him firsthand. So I guess with that introduction, I hand it over to you, Ashirwad. Thank you.
Thanks, Kiran. And welcome you all on behalf of Khagol Mandal for this second lecture in our series, which we have recently started. If you have attended the first one, it was how to select a telescope. Those who are enthusiastic to buy a telescope, then Shailesh Sansare covered it very well, giving a brief about what all various types of telescopes are and all those things. So at this point, I will address the next bit, that is, suppose you have purchased a telescope, then, am I not audible? There is a message.
No, you are audible.
No video.
No, in fact, you are absolutely audible.
Okay, all right. So, Sudesh, you may want to check what is the issue with you. So let me continue. So today's focus is that you have purchased a telescope and you are planning to visit a dark site and watch certain objects. Then, based on my passion, as Abhay mentioned in our flyer and Kiran's wonderful introduction, thanks Kiran, I'll just give my experiences, and I have tried to put it in a very simplistic way so that hopefully you can enjoy this presentation. So I will try to switch to the presentation now, and Kiran, just let me know if you can see the presentation. Share the screen. That's all what I need to do, right?
That's right.
So is the screen shared now?
Not really. Yes.
It's there.
Yes.
I'll go full screen now. Let's see if it is even better now. It's better. It's
Yes.
all right. So selected observation targets for your telescope and for your passion. That's a topic. So intent of this talk, as I said, having covered which telescope to purchase by Shailesh, this focuses on which objects to sight through your telescope. We will not cover specifically the constellations in English or Indian constellation with the naked eye. Of course, if there is a question to that effect, I'll address it. But the intent is to concentrate on the objects which we sight through the telescope. So, tips for observation session. That's my first 2 minutes, followed by the actual objects, obviously the moon, planets, binary stars, nebulae, clusters, galaxies, and comets. That's where I will try to end, hopefully I'd say 8:15 types, hopefully 8:15, 8:20. And then over to you for question and answers. Let's see how it goes. So tips for observation.
Ashirwad, just check if everybody is comfortable with English. Otherwise, maybe once in a while also.
I saw names who are speaking. So I probably would, rather than switching between Marathi and English, I would rather continue in English. That is what I thought. Correct me if I'm wrong. And if someone is not comfortable with English, just type it in the chat. I'll try to put the point in the Marathi. Let me do the other way. And feel free to, if it is a question of explaining again, especially in Marathi, put it in a chat. I will right away take it. But the general question answer session, we'll put it at the end. So let's distinguish these two kind of chat messages. Kiran, would you be able to manage that chat portion?
Yeah, absolutely.
So to continue, let's see, you got a telescope. Next immediate thing, one which comes to your mind is select a proper site or a dark site away from a city. Please mute. For a formal search of a dark site, there is a nice website called Dark Site Finder, which shows a light pollution map across all the cities, across all the full world. And with the help of that, you can get some rough idea. It's not absolutely perfect because you actually visit the site and whatever you had seen on the website, you may reveal that there are some stray lights in certain direction on the horizon, etc. So be prepared for these surprises. But generally, your search will not go absolutely wrong. Next thing, it's highly recommended to wear thick trousers, shoes, full sleeves, etc. I'll give one quick instance. I mean, Khagol Mandal owns a site, place called Muroli, which is outskirts of Badlapur area. And it's not truly a jungle site, but it's a farmland area. So there are scorpions, there are snakes, all these kind of things. So it's good to have thick trouser shoes, and this dress code will at least save you in case you encounter any of these kind of things, experiences. The next thing is, please have a good star map or a nice app handy with you so that you can locate the objects which you are going to point through telescope. Next thing is, keep red light torch handy, because when you are in the dark side, the pupils are dilated naturally, as we all know. And red light usage minimizes the impact of dilation, because if you have any other light, say our typical yellow bulb or any tube light and all that, the pupils will, whatever nice dilation has happened, they will contract and you will see all the things very dim. For example, if there is a Milky Way in the sky, guaranteed that such a light which pollutes will simply remove the Milky Way sight from your eyes. You will not be able to see it, at least for next 10 to 15 minutes. It's that bad effect on the pupils. Red light minimizes this bit. So have a red light torch. They are available. The next thing is, keep one high power eyepiece and one low power wide field eyepiece handy, because these are the ones you will be flipping again and again to side objects. The last slide on this tips business, practice averted vision. Now, what is averted vision? It's a technique for viewing faint objects where we use we sight object which is close to the given object, slightly away from the main object, and then try to imagine that we are trying to see that other object. So if there is a nebula or cluster and there is a close by star, then you start focusing yourself on that star, and then through this particular technique, try to imagine that there is some object close by. And this works very well because the way our sensing machinery inside, I'm not a biologist, but the sensing machinery is there inside the eyes. The sensitive portions which go for a dark, the light patches in the dark areas, and the resolution that is slightly off axis in our eyes. So on axis, exactly at the dead center, there is a star, and off axis is our wonderful object, which you will be able to see. And this averted vision technique helps you to see that better. Locating an object. If there is a go-to telescope, the onboard computer can drive the stuff through its motors and get you the telescope pointing to that required object. If you don't have a go-to telescope, it's more fun. So I would suggest just keep your go-to stuff shut down and try to locate it yourself. It's very simple. Suppose my friend is coming to my place for the first time, and he's in some area, say half a kilometer, 1 kilometer radius. Then I call Kiran on the phone and say, Kiran, do you see this post office? Then there is a lane opposite to that. Just take that lane. And then there is so-and-so restaurant nearby. Just pass that. So I start guiding him, and he follows those instructions step by step. And eventually, he's right at my doorsteps. I can do the same thing for the stars. Go and locate the bright stars first in the sky. Get acquainted, align yourself with the sky. Then with the maps, get the constellations. And then wherever that object is lying, try to get there through some kind of a star hopping. Okay, I got this bright star. Next to it, there is some 3 stars which are in the triangular pattern. Let me get them. Oh, then there is some small pentagon kind of a structure. Let me go there. So like that, you step by step go and finally hit the object which is the intended one. All this star hopping is done with a wide field eyepiece. So you recollect the 2 eyepieces I said, the wide field and the high power one. So all this star hopping has to be done through the wide field eyepiece. Let's go to the next one. Are you able to see the slides? I hope so. Because now we are getting to our first object, the moon. Good lunar maps are required to actually understand and interpret the lunar surface. Personally, I use a paid app called Sky Safari Pro. Wonderful app. It does a lot of things. And if you locate moon on the Sky Safari, and doing the pinching technique, if you try to, the way we expand the photos, if you point 2 fingers on the moon and try to expand, it will simply expand and you will be able to see the names of craters and mountains, valleys, all these kind of things. There is another one called Virtual Moon Atlas. Just go to the Google and look for a Virtual Moon Atlas, and it will give you tons of information through its maps on the PC though. Now, here is our first bit for sighting through the telescope. Crescent moon. Very simple thing. We have seen it many times. A crescent, Pratipada, Dvitiya Chandra, Tritiya Chandra, so and so forth, Ashtami Chandra, and so and so forth. So look for the initial 3-4 days. This portion, the tips, the crescent portion, if we draw a picture or if we tell some youngster to draw a picture, they will do a very nice curved kind of a picture. Is moon like that? In reality, no. Moon has mountains and valleys. Now, one of the scientists called Bailey, he first explained a very interesting phenomena with respect to solar eclipse. When there is a sun, when there is a moon, which does a occultation or comes in front of the sun, we see the solar eclipse. So when there is a complete ecliptic sun, if it is a annular or it is a complete, then this imperfect moon is not perfect. It has got valleys, it has got mountains, all these kind of things. So what happens? The light of the sun passes through those gaps, and so you see something called Bailey's beads. Similar effect of like a Bailey's beads kind. It is, Bailey had explained it for solar eclipse, but our moon crescent also shows those effects. So the crescent is actually broken into pieces. That we can see wonderful in high power magnification. Next thing is craters of the moons, especially the craters are seen best where there is a slanted shadow. So when there is a crescent or a gibbous moon, try to see the edges of the moon where you will see wonderful craters. I have just named a few craters like Tycho, Pitatus, Copernicus, and there are hundreds and thousands in a lunar map you can see. Next thing is dark areas. On the moon, we are able to see dark patches. Earlier, we used to call, okay, there is some picture or there is a hair and so on and so forth. These are all stories. But in reality, it is a lava settled and they are called oceans, and they are named as Mare Crisium, Mare Nubium, Mare Tranquillitatis, and so on and so forth. Again, a good moon map will show it very clearly. Then there are mountains. Mountains are seen as some kind of wavy patterns in this thing. So if I try to see the pillow and all these wrinkles kind of things, you will be able to see in on the lunar surface with a high power magnification of an eyepiece. There are very interesting spatial features. It's all these things is caused by meteorite impact and comet impact on the lunar surface, and much of it. And there are some nice spatial features I call, because they are not mountains, they are not dark areas, they are not craters, but they are very interesting things. So these are Rupes recta, Rupes cauchi, and there are few more. So I actually show you a photograph of some of these things. And then I try to play a video clip of moon occultation to one of the stars called Aldebaran, because these are the things to watch from the telescope. These are not the things to watch from the naked eye, once again. So let's go to the next slide. So if this is, you see the mouse cursor at the crescents. Now these crescents are not smooth. At a high power magnification, you will see these edges are broken like this and not the smooth ones. That's what I'm referring to when I said Bailey's bead kind of effect, because this kind of effect you see in the solar eclipse for the sun's view from the earth. When this dark is moon and sun has been occulted by moon, and then the bright nice sun is all dark except its edges where you see some bright light of the sun which is leaked because of imperfect lunar surface, as I said. But here we are talking of lunar surface itself being lighted by the sun and the broken edges at these portions. That's a wonderful experience. Next thing is just a lunar image. I just lifted it from the net and you can see some of the craters, Mare Tranquillitatis and Mare Crisium and Mare Nubium and things like that. In the telescope, you will be able to see things much better than the naked eye, especially the craters. Next one, that interesting object you recollect, I mentioned about Rupes recta. So it looks like a sword, you know. There is a handle here and there is a wrinkle. It's actually, it looks like a sword, but it's just a formation on the moon caused by various effect which the moon has faced over all these hundreds and thousands of years. So there is some line wrinkle and there is some shape here. we happen to see it and we have named it as Rupes Recta. It's a wonderful sight to locate and see it in the telescope in the high power eyepiece. Now I'll try to show you occultation of Aldebaran moon. I have photographed it, video photographed it, so hopefully you will be able to enjoy. Give me half a minute and let me play the things. Kiran, just tell me if people are not able to see it. Let's see how to address it.
Sure. And by the way, there are a few folks whose videos are on. Could you just switch off your videos so that we can save some bandwidth? When you ask questions, that time you can switch on your videos back. Yeah, go ahead, Ashirwad.
Yeah, the video is on. I'll play it once again. You see moon, the dark side of the moon, and here is the small spot. That's star Aldebaran, Taurus.
No, Ashirwad, the video is not on. I think you have probably only shared the presentation instead of sharing.
Oh, okay. Half a minute. Let me try. So let me see how best I can enable the video.
Ashirwad, stop sharing, then start sharing the whole screen instead of just one window.
Acha. Okay, so stop share, done. Next thing.
Now share the whole desktop instead of sharing just one application.
You mean advanced sharing options?
No, it's there in sharing only. When you say share, it will show you on the screen what all things you can share. It shows you the app and it shows you the desktop.
I got it. I got it now. So I'll say share the screen.
Yes, and then play the video.
Okay. Do you see the complete screen shared now?
Not yet. Yeah, it's just about starting, Ashirwad.
Now you see?
Yeah, yes.
So here is Aldebaran. Here is the dark side of the moon.
No, wait. The
You
video
are
has
able to see Aldebaran?
Ashirwad, the video has not yet started. It's only your desktop we are seeing. So let's see.
Are you able to see now?
No, I think it is a bit of a delay probably.
Okay. Are you able to see now?
No.
Oh God. I think in the interest of time, I'll just skip it.
Yeah.
Forget it. So let me go back to the presentation. Sorry, folks. I think the technology is not permitting us. You are able to see the next slide, the planet.
No, not yet. We're still seeing the desktop. I think you have now shared your Explorer, not the whole desktop.
Okay. So I have stopped sharing now.
Yeah.
Let me share it. Is the presentation back?
One moment. Yes.
Huh?
Yes.
So now let me go to the slideshow mode. Planets. Are you able to see the planets? Kiran?
Yes, Ashirwad. Go ahead.
Okay. So the planets, Jupiter, Saturn, Venus, and then I have bunched Mercury, Uranus, Neptune. The reason is some of these ones which are very prominent, I have separated them out. So Jupiter, what you can see in the telescope, you can see the surface features, the bands, the red spot called GRS, great red spot, 4 moons, Io, Europa, Ganymede, Callisto, and then shadows of the moons on the surface of the Jupiter also can be seen, but it requires a larger aperture telescope. 18-inch I see all these things really superb. GRS again I can see it really well. in my instrument. Bands, I can see at least 10 bands, but in a small telescope, say inch telescope, you will be able to see 2 bands. So actually what you see on Jupiter, it's just a white patch and there are 2 parallel lines close to each other. And these are actually bands caused by the typhoon's Vadal, basically, Jupiter Virchi. That is why you see these bands. Then Saturn, you see surface features with the big telescope, but otherwise you see rings very well. And there are multiple rings. And between the rings, there are gaps, which is natural. And these gaps, as a gap, you can see the rings. There is a outer ring, then there is an inner ring, and between 2 rings, you see a black patch. That is called, named after a scientist called Cassini. So it is called Cassini separation. So this Cassini separation you can see with a large aperture telescope. 18-inch you see very, very well. And then moons, again, typically on 18-inch you see 6 moons. A small telescope will show you 1 or 2 moons. Titan, most of the telescope you'll be able to sight. Titan is one of the largest moons of Saturn, the largest moon of the Saturn. And Venus, the inner planets, Venus, Mercury, they exhibit phases like crescent of the moon. So if I show you Venus crescent, you will not be able to distinguish, oh, is it a Venus or is it moon? So that kind of a Venus you will be able to see. Mercury, Uranus, Neptune, they are seen as very small spots, even in the large aperture telescope. So I will not really cover. Now coming to the photograph, Jupiter, you are able to see the first photo, Jupiter?
Yes, sir.
Yes, sir.
Yeah. So Jupiter, and there are these 2 parallel lines. You see, I have specifically selected that particular photograph from the internet, which is meant for small telescope kind of a thing. A large telescope will show Jupiter much bigger. If you see Hubble or any of the famous telescopes, you will see gigantic Jupiter. But that's not what we are talking. We are talking of your typical 6-inch, 8-inch, 10-inch kind of instrument. And there are 4 moons in a line you can see. So that's how you typically see Jupiter in an average amateur instrument. Next one is Saturn. Saturn, you see a blob and some elongation, which is Saturn's rings. Now, if it is a bigger telescope, you will see Saturn itself bigger, and the rings itself you will be able to see much wider, and the gap between the rings also you will be able to see. And that's what is named after Cassini separation. And 6 moons also you can see typically for a bigger instrument. The next one, Venus. So this is not moon. This is the Venus in a crescent form. And the crescent, smaller crescent, slightly bigger one, gibbous Venus, and a full-blown Venus. These are the kind of, this is the way Venus appears to us in the sky at different times of the year. Just recently, few days back, probably 15-20 days back, I was at my personal observatory, and a much thinner crescent was seen. Later on, Venus went behind because it was rising and setting along with the sun. Now, in the recent past, it has started rising in the morning sky. Earlier, it was evening skies when I saw it, nice crescent, thin crescent. Now it is in the morning sky. So that's how Venus, and as the days pass, that crescent will also go rounder and rounder. It will eventually go gibbous and it will be full round, very bright. That's what will keep happening as Venus goes round the sun and as we keep observing from the Earth. So I'll go to the next slide now. The next object after the planets is binary stars. Binary stars are the stars which are close to each other and it's not, if they are optically close to each other, they just appear to be close by, that's one thing. But sometimes the stars are bound to each other gravitationally, and they circle with each other. म्हणजे in मराठी आपण फुगडी घालतो म्हणतात तसा प्रकार आहे. So little bit of a theory, because I'm assuming that we are talking about a telescope in hand and a dark side with telescope. So depending on telescope's aperture or its diameter of the main lens or the main primary mirror, somebody called Rayleigh, one of the well-known scientists in physics, he has done the mathematics, and he said that if the stars are very close to each other and you get a few telescopes in the field, I have my 18-inch, somebody else has his 8-inch, somebody else has his 10-inch, and so on and so forth. And depending on each of the instruments' capabilities, the way binary stars are seen is different. Why is it so? All can go for a particular magnification, the same magnification. So say they try to separate the binary stars pair, which is say few seconds in terms of degrees away from each other. So let me stop rather than sharing. Let me see. You are able to see the slide, right?
Yes.
So let me point to the image on the left side. So between two stars, what is the angular distance? So that is the separation I'm talking. Certain binary stars may be this close. Certain binary stars may be slightly far apart. Certain binary stars may be quite far apart. So mathematically, it is called, oh, they are so many arc seconds close. Some other stars are, oh, they are so many arc minutes close. Some other stars may be, they may be half a degree close. So it depends on how close they are. Now you take the pair which is very, very close and you magnify it through a telescope. Then you will see a separated image because you have magnified it. Simple. Now you take 3 telescopes. The 8-inch will not show you the crisp image. It will show you a diffuse image. 10-inch may show you slightly better image. 18-inch will show you much crisper image. If my friend has got 24-inch telescope, it will be much more crisper. Why is that so? Because there is some mathematics. The person who first put it up was a person called Rayleigh. So angular separation in radians is approximately equal to 1.22 into the wavelength of light and divided by aperture of the telescope. So when you purchase a telescope at that time itself, the mathematics has fixed what is the best angular separation you can see in your telescope. If the stars are closer than that, and if I challenge you guys, try to show me that star pair, you will put more and more magnification, you will use better and better eyepiece, no use. You will not be able to see the stars clearly. You will see them as diffused, the way you see in the right side. The only way is to have a higher and higher aperture and be able to see the stars much more crisply. You will see in the next slide what it means. So I have chosen few stars. There are hundreds and thousands of binary pairs. I have chosen few 6 of them. One is Albireo, constellation Cygnus. It's a very colorful duo. So that color contrast is wonderful to see. Every time I see it, I get some joy out of it, having seen it 100 times so far. Rigel, constellation Orion. It's a very close one, but not very close though. The next one is Mizar Alcor. It's Ursa Major constellation, Big Dipper. In Marathi, we call it Saptarshi. In Indian marriage tradition, there is at some point, the Guruji tells that bride to point it to the bridegroom, and bridegroom has to see it. Probably the idea could be that close pair, if bridegroom is able to see, then our eyesight is good. That's what my interpretation is. Because I did an interesting calculation. That particular separation between Mizar and Alcor, I don't recollect how many arc seconds it is, but whatever arc second is, I tried to feed it in the Rayleigh criteria, and I tried to find out the diameter of the aperture, a telescope or instrument, what it is. You know the number it gave me, the Rayleigh's criteria, it gave me 7 mm. So 7 mm is a typical human dilated pupil in the dark sky. So bridegroom ka 7 mm tak jata hai, good. If bridegroom has problems, it can't go to 7 mm, she will not be able to resolve it crisply. Aisa hai. So don't ask me who in our old mantras and all that, who invented this and did they calculate, I don't know all these things. But mathematics shows this is what it is. Mizar, interestingly, itself is a double visually. And if you go to the internet, people say it is actually 4 because spectroscopically some physics techniques used karke, they have been able to see that there are actually 4 stars in Mizar. Alcor itself is double itself, but through sophisticated stuff, infrared observations, you can prove that it is a double. But even in 18-inch, I see Mizar as 2 stars and Alcor as 1 star. The next one, interesting stuff I chose for you all was a star called Double Double. It's actually 4 stars, constellation Lyra, and one can split 2 easily. And if you got a fair amount of instruments, say even in 10-inch or 12-inch, you will be able to see complete 4. So now let me show you the quick pictures. If you are able to see the next slide, Alberio, wonderful color contrast. Mizar, double, Alcor single. This is some other star in the same area. Rigel, relatively close one. And if you see double double, here are 2, here are 2, total 4. So double double. You see the pictures? Shall I move to the next?
Yes, Ashirwad, we can see those.
The next one and last one in binary stars area I chose for you all, Polaris or Pole Star, constellation Ursa Minor, and or Small Bear. And then every time when a good astronomer for their astrophotography, we do the polar alignment or 2-star alignment, which I do for my 18-inch internal computer called DSC. I encounter pole star. I have to see that and I have to feed some message to the internal computer. I am teaching the computer what I am supposed to see in the skies. So that is called alignment. So if you attend our astrophotography workshop, paid one of course, you will be able to learn much more about all these things which I am talking. The next and the last one I have chosen is Sirius and Sirius B. Sirius is the brightest star we see with the naked eye. It's in the constellation Canis Major. So now I'll show the photograph of Polaris. Polaris, you see, pole star and it's Polaris B. Now, here, Kiran, you are able to see Sirius?
Yes.
And you see a small, tiny dot here?
Yes.
So, it's a very sharp separation. And if you have got a good instrument, I'm saying good, just don't buy any 18-inch. If the mirror is not perfectly ground, I mean, if I have to use the mathematical terms, there is something called a Foucault test. It is called a Schrell ratio. So all these things have to be extremely good for that mirror if you are purchasing. So 18-inch mirror, from somewhere you purchase which is not of good quality, you will not be able to see Sirius B. You will be able to see it only if you got a mirror of certain quality. One of my very close friends in USA had visited USA to my daughter, and I had an opportunity to see it from his 15-inch. He has got a good instrument from one of the well-known telescope makers. His 15-inch does not show Sirius B because the aperture is small. So you need a larger aperture and you need the mirror ground to that perfection. It's a tough target because the separation is small and Sirius A is too bright to mask this separation. Now, some story, don't expand much in the chat session later on, but I can't resist myself telling about it. There were 2 anthropologists, Marcel Griol, I don't know how to pronounce, and Germain Dieterlen. These 2 guys were interested in the tribal and things like that. So they visited some tribe in South Africa. Their name is Dogons. And these Dogons people, they were interviewing, and they used to try to collect the data, how they live, what they do. And these Dogons were supposed to be completely cut off from the human civilization. We are talking of 1920, 30 kind of a time frame. And they didn't know anything. So completely cut off guys. And these people suddenly were surprised to those guys. Over a period, they became close friends, and these Dogons started sharing certain things. Some fine day, this Dogon said something about this bright star, and these people noted all these things. These are anthropologists. These people, Marcel and Germain, they just noted down in their diaries. And suddenly, as the book got published, some people who understood more about astronomy, they tried to read it, and they literally fell from chair, because the Dogons had said that this Sirius has a companion called Sirius B, and every 50 years these people celebrate in the name of Sirius. You know why? Because these astronomers knew that this Sirius B, so to say white bar, it rotates around, revolves around this main star Sirius A in around 50 years. Now the question to astronomers is, how these Dogons know about this? Who told them all these things? Anthropologists didn't know, they just recorded. So now people have all kind of theories. Somebody would have leaked them earlier. Is there some extraterrestrial message? Do Dogons have origin in extraterrestrial? All kind of discussions go on in the internet. Read that. Those who are interested for amusement, read for amusement. Those who are interested for this ETs and all that, read from whatever perspective you want. But what I said is a fact. Tribe Dogon, Marcel and Germain's work, the noting about these guys, and their experiences about Sirius, about 50 years celebration and existence of Sirius B. So that's it. Let's move to the next. Special stars. I've chosen 3 special stars. There are again many more, but small telescope. So I don't want to hit you with lot of messages. The first one is La Superba, constellation Canis Venatici. It's a carbon star, bright red. Literally ऐसा red LED दिखता है ना on our Tata Sky or any of those kind of things. Like that you see. It's the many stars you see are reddish. Betelgeuse is reddish, slightly yellowish, or yellowish come reddish. Rigel is blue. No, this bright red is much different than that. And R. Leporis is even red, deep red, literally LED sitting in the sky. Constellation Lepus, it's again a carbon star and literally bright red. It's known as Hind's Crimson Star if you go to the your star maps and try to see it. And the third star is Eta Carinae, constellation Carina. It's in the midst of nebula and cluster, and it's famous because whatever stars we see in the naked eye, typically we see around 6,000 stars in the sky in the dark side. You go to Nubra Valley or Pangong, you will see 6,000 stars with a good eyesight if you have, of course. And otherwise you will see less, 5,000 stars or 5,500, depending on whatever, you know. But let's talk of ideal situation, a good eyesight and a good real dark side. Now, in all these stars, and there are so many thousands which you don't see, but you can see it in the telescope. Hubble can see more, James Webb will be able to see many more, and so on and so forth. My 18-inch will see many more, your somebody's 8-inch will see slightly less, or whatever. In all these stars, if you put in one basket and ask a question to someone, Mr. Scientist, give me names of few highest luminous stars. If it is distant, I'll see it small, doesn't matter, but actually in its own right, it is very luminous. See, it's like a very distant torch. It is but if you get it very close, you will see bright. But if it is very distant, you will see a torch which is small enough. So to be fair on all the stars, you don't ask a question who is closer. You just say कि यार close है तो bright दिखेगा ही मेरे को. No, you ask a question to a scientist. Tell me which are truly highly luminous stars and massive. And if it was closer, I would have seen it as a huge. But if it is very far, maybe I may be seeing it as a slightly faint. Scientists will list a few stars. Eta Carinae is one of them. And Eta Carinae ke around whatever that nebula is there, it's a starburst some kind of a nursery where stars are being born, and many of the stars are really massive in that area. Interesting. So this is La Superba, R. Leporis, and Eta Carinae. Eta Carinae is, I have just pointed in the circle, but you go to your star maps, you note down these names. Anyway, this is being recorded. So at a later date, you can refer to our Khagol Mandal's YouTube channel, subscribe it if you have not, and then look at this presentation, come to this slide and look at Eta Carinae position and check with your star map. You will be able to see it at a later time also, no problem. This is R. Leporis and this is La Superba. Next one, we'll go to nebulae. I think I must hurry up now. And the interesting session actually starts now, because now we are covering deep sky objects, nebulae, galaxies, clusters, etc. So I'll just zip down fast. M42, it's a nebula in the constellation Orion. It's a nursery where stars are being born, and this whole cloud is being powered by the light of the newly born stars. M42, you will see a very nice trapezium, and many times they are known as ABCD. And close to ABCD, there are two other stars you can see, E and F. These E and F components are also seen in a high aperture telescope. 18-inch, I see it very crisp. If there is a bad 18-inch with somebody, they will not be able to see, they will not be able to resolve. Remember Rayleigh's criteria? They will face the music. They will not be able to resolve this distinct E and F. But ABCD, they will be able to see. They are relatively far enough. If it is a smaller instrument, 10-inch, but very nice one, then probably you will see E and F in a very good sky condition, but not always. 12-inch, many times yes. 18-inch, invariably I am able to see E and F, whatever situations. Next, M57 ring nebula. So it's a planetary nebula, and it is caused by gases which are expelled by a dying star. We are not covering the physics here, but you can keep attending our series. Someday, sometime, I think we will cover it, or there is lots of material on the net anyway on this. So dying star expels this kind of things, and there is a planetary nebula. It's in the constellation Lyra. Incidentally, that this is the same constellation where I mentioned about double. The next one is Eta Carinae. We spoke about Eta Carinae a lot, and that's a wonderful sight to watch in the telescope. Next one is Rosette Nebula, constellation Monoceros. So what you can do is, what I have done is, there are very nice pictures, literally hundreds of pictures of this Rosette M42. M42 is like photographed a lot. There is all the astrophotographers, day one, they photograph moon, some of the planets, and then M42 for some reason. It's a pet object. So some of these objects you will see so many photographs, but I have chosen only those photographs where the view of this object will be similar to what you are seeing now. Otherwise, a wonderful, beautiful, colorful image from Hubble, you will be able to see on the net. Don't expect that from your 18-10-inch. Even 18-inch does not show Rosette to me like that. Please remember. The next one is Trifid Nebula, a wonderful sight in the midst of our Milky Way in the constellation Sagittarius. The Milky Way passes through Sagittarius. We will be able to easily locate M20 or Trifid Nebula. M20 incidentally is a catalog number because scientists have gave the catalog numbers. Who did it first? Messier, Charles Messier, somewhere around 1700, 1600 century. So that time he did that, and he was actually a comet hunter. But some of these objects which are stationary, they are not like comets. They come and go. They are always there. They are there from 16th century, 17th century, even today. So he identified those objects and gave them the numbers. So this particular object, this Trifid kind of a beauty, he gave the name Trifid Nebula, and he gave the number 20. So people say Messier 20. So that's what it is. So like that, the next one is Messier number 8, M8. It's called Lagoon Nebula because it's like a shape is like a lagoon. Again in the Sagittarius, again in the Milky Way region, very close to the earlier one, that is M20. So this is M8. So this is Messier who gave these numbers so many years back. And later on, as the technology developed, people formed newer and newer numbering schemes. Telescopes were bigger. So whatever Messier's work was there, he actually completed work with 44. People further identified some more. And the Messier catalog is known from M1 to M110, M110. Whereas the new catalog with lots of big telescope and thousands of more objects added, this new catalog is called New General Catalog, NGC. And again, in the new catalog, again, they have to number these things. Na? So Lagoon Nebula, what Messier gave the number 8, the NGC catalog gives the same object a different name, 6523. Now go to the next one, M1. This is the number 1 in Messier's catalog, M1, Crab Nebula. In the new general catalog, it is numbered as NGC 1952. So like that, you will always find a mapping between Messier numbers and the new general catalog numbers. Its a shape is like a crab, and this whitish patch you see in the center, and even in the 18-inch, you see this whitish patch much more prominent. I have picked up that image, which is typically seen in an 8-inch telescope in average dark sky conditions. It's in the constellation Taurus. And this is a very interesting object because in 1054 AD, Chinese astronomers observed a star in the daytime also, and it was observed as a very bright star for 23 days. I'll go to the little bit of physics in one line. It's a supernova. That star had exploded. It was at its death cycle and a massive star. So a star can become a nova if it is small. If it is a huge, it becomes a supernova. And that star, very bright, expelling all kind of material in the skies, was seen for 23 days. What do we see today? The star is dead. The expelled material is this Crab Nebula, which is expelled material from that dying star. And there is a Crab pulsar. I won't go in what is pulsar today because that's out of scope for today's discussion. We keep tuned with Khagol Mandal lectures. Somebody will explain in the future more about this. The next one is Dumbbell Nebula because it's the shape of a dumbbell. Messier named it as M27. New General Catalog names it 6853. Constellation Vulpecula. The next one is Owl Nebula because it looks like owl. Constellation Ursa Major, M97 or NGC 3587. Now I'll come to the next bit, that is clusters. Stars closely packed together are seen as clusters. It's like you are in the terrace on your tower or skyscraper, and people are coming, going, and somewhere somebody does some mischief. Typical tendency in our cities, 20 people will come and over each other's shoulder will start watching kya chal raha, kind of a things. And you see that crowd from your terrace. So if the stars are seen in this crowd form in this whole night sky, they are clusters. Now, globular cluster is a kind of a thing. You see, in Diwali, we light some of not bombs, but Shobhe Se Fatake, the beautiful rocket kind of things. They'll go up and they'll explode, and there are all small particulate, burning particulates. They'll emerge out of that globe, and they'll expand, and eventually that globe kind of a thing will die down. You see something very similar here, and they are called globular clusters. And one of the finest is in the constellation Centaurus in the southern skies, NGC 5139. It is not present in Messier's catalog, so there is no Messier number for Omega Centauri. The next one is M13 NGC 6205 constellation Hercules. In 18-inch, I see it very similar to Omega Centauri. I can resolve all the individual stars, but I've chosen this fuzzy image because 8-inch or 10-inch will show it like this only. Even if you put high power eyepiece, no use. Remember Rayleigh criteria, you will not be able to resolve the individual stars. You will see it as white blob. Can't resolve the stars. 18-inch, big aperture, Rayleigh criteria you work out, you can resolve the individual stars. Put a high magnification, see a wonderful, highly resolved globular clusters. Next one, slightly parse, M4 in constellation Scorpius. But I think even for 8-inch stuff, 10 or 12-inch, you can resolve them a bit. 18-inch, I can fairly resolve them well. Then the clusters which are just slightly random shapes, but not this globular kind of pattern, they are called open clusters. One of the finest and easily prominent is Kritika Nakshatra M45 Pleiades, constellation Taurus. 7 sisters. Many times you would have seen it in the skies, in the dark skies, you will see that fuzzy patch. In the binocs, you see this. In the 3-inch, 4-inch, 8-inch, easily see this. 18-inch, very bad instrument because 18-inch magnifies so much that this Kritika does not come in the same field. I see field only like this. The next one, again a beautiful one, you see a hazy patch. Cancer. Interestingly, I will spoke about averted vision. It is the best object if you want to practice averted vision. It is in the night sky these days. You can see it. Kiran, am I audible? Kiran?
Yes, Ashirwad, you are audible.
And you can see the slide now because
Yes,
the
yes,
internet flashed a dirty message. The net is a bit unstable.
No, it's absolutely fine. Go ahead.
Fine. Thanks. So constellation Cancer. So there are, I'll quickly name the two key stars, two brightest stars in this Cancer constellation. One of the stars is named as, yeah. One of the stars is named as Acubens, and another star is named as Tarf. So they are pretty close to each other and to this cluster called Beehive cluster of Prasip M44. So what you do is concentrate your focus on Tarf, or actually, to be honest, if I am there or some expert seasoned person is there, they will concentrate on yet another two stars called Icelus borealis or Icelus australis. So concentrate on Icelus australis or borealis and try to imagine that you are trying to see Beehive cluster, Beehive open cluster. You will clearly see a white patch. But focus your eyes at white patch, probably will miss it. Averted vision comes into play. So practice averted vision, looking at Beehive cluster, not looking at it, but try to look at Icelus primus or Icelus borealis or australis or Acubens Tarf, and try to imagine there is some white patch in the vicinity, and try to see direct averted vision. Ekdam must dekhi. So that is what is averted vision. Practice it here. Another cluster is M46, NGC 2437, constellation Puppis, and there is a slight hazy planetary nebula patch here called NGC 2438, and this view is wonderful. All the stars in the open cluster, and there is a sudden white patch here. But interestingly, this particular white patch is not part of this open cluster because there are advanced physics instruments people have on Earth telescopes and Hubble and James JWST. You can see that these stars are actually at certain light years away from us. And then you will find that this particular object here is not at the same distance. It is probably half of what these other stars are. That is what astronomers have found out already. You just happen to see it because it is in the line of sight of all these stars. So all these are seen, this is also seen, but this is actually closer, and the other guys are much further. The next object, this is interesting one. Constellation Perseus, and there are two open clusters closely sitting to each other, and excellent view in the wide field eyepieces. In the high aperture telescope, and if you have either wide field or a high power eyepiece, you will see their distinct colors, some red, some yellow, some blue, wonderful colorful stuff you see. Perseid Jabber cluster, NGC 869, NGC 884. The next one is a nice open cluster called M11 wild duck, because the way this in the medium telescope or the binocs, you see the inner stars in these open clusters, the bright ones, you feel as if there are ducks flying in the sky, white ducks. So that's why it is called wild duck cluster. Constellation Scutum, and it's in the Milky Way area, so you see surrounding lots of stars when you watch this. Same effect you get in the open cluster M7, constellation Scorpius. In the rich portion of Milky Way, this cluster lies. So it's a beauty. I just forget everything when I'm watching these kind of things. Again and again, I keep watching. Nice Milky Way view and this open cluster, bright objects closely packed to each other in this pattern called M7. Then one of the richest clusters, because sometimes the clusters don't have much stars, like Pleiades, if you saw, Seven Sisters, it's not that rich. But if you see M37, very rich in the number of stars. Constellation Auriga, M37. And the last one in this clusters business is, I have selected for you, and there are many more, of course. It's open cluster Owl, because there are two prominent stars in this cluster. You can't miss it. Constellation Cassiopeia, NGC 457. Immediately you are able to spot it. Again, when you have a nice app, you start going through GoTo or use star hopping technique and try to locate these clusters. It's a fun that on the day one you are not able to locate M42 nebula, Orion nebula, or M31 galaxy, or this open cluster, Owl cluster, or all these things. But as you practice more, you will be able to locate them, and then the fun starts. In fact, the fun starts on the day one that you are struggling, then you get it after a few attempts. Then you are able to locate it very fast, and so on and so forth. So always fun is there. Now, the last part, galaxies. Galaxies are actually like a Milky Way is a galaxy, which is really a few billions of stars packed together and staying together as one entity. And all these stars rotate around the galactic circle. So unlike nebula or open cluster, galaxy is a system of stars where all these stars revolve. They are bound to each other, bound to the galactic center, and they revolve around that center. And the photo in front of you, M31, is a very special photograph. Why? Because you go to a very dark sky, not like Mumbai, Pune, and all that. You go to Pangong, Mumra, you go to Naneghat in Maharashtra, or you go to, earlier, even my place in Nashik was that dark, but there is some work going on because of Samruddhi, and there is a bit of a night pollution. But if it goes away soon, hopefully after a year, 2 years or so, I'll get my dark sky back. And in such a dark sky, you are able to see lots and lots of stars, around 6,000 stars in a pitch dark sky. Then you ask your expert friend astronomer, show me that object. Maybe it is not a star, but it is farthest. So Sirius is around 8.5 light years. In the Centaurus, there are two stars, Rigil Centaurus and Hadar. They are around 4.5 years light years away from us, and so on and so forth. So these kind of stars you are able to see with the naked eye. Then your astronomer points you to the constellation Andromeda, and and then the astronomer is able to point you to the object there, which is very, very faint. And he says that you are able to see the farthest object with the naked eye, and that object is a galaxy all by itself, at least 3 times larger than us. and it's 2.3 billion light years away. So it's the farthest object you can see with the naked eye. Andromeda galaxy, and it has got two other satellite galaxies which are bound to the main Andromeda galaxy gravitationally. So this is M32 and this is M110. Even in the binoc, with the naked eye you can see this. So with the binoc you can see, in the 8-inch you can see, in the 18-inch you can see, it's much better view. All the three with a wide field in a single, in a wide field I can see either this or I can see this. I can't see all the three together in 18-inch. But in 8-inch, 12-inch with a reasonably wide field, you should be able to see all three together. Next, M51 Whirlpool Galaxy. I have chosen this picture purposefully. So those who are really enthusiasts in astronomy, go back, note down this number. If you forget, go to our Khagol Mandal YouTube channel, subscribe it, and try to see my presentation, which Anurag will load soon after this, the recorded session. And look at M51. There is a nice whirlpool kind of a thing around this galaxy. So this is M51, and this is another galaxy which is gravitationally bound to it. It's called NGC 5195, constellation Canis Venatici. So this wonderful view you can get in a larger aperture, dark side. At my place near Nashik in 18-inch, I can see this whirlpool effect very nicely. But I have not chosen the picture for you here because a typical 8-inch, 10-inch, unless you go to a very dark side, you will see this fuzzy picture. You will not see this as a nice whirlpools. Next one, in the name of Bode, who did the work, who first discovered these two galaxies, M81 and M82. Wonderful duo you get in the constellation Ursa Major. And this one is called Cigar Galaxy also. In a good instrument, 12-inch, 14-inch, 16-inch, and 18-inch and above, with a nice eyepiece, you are able to see the dark lanes of the galaxy. The dark lanes are because of the overall galactic structure, the dark clouds and the dark spaces. And the whole galaxy is not lighted. It has got the dark spots which are very specific, just like our fingerprints. Every galaxy has its own, so to say, fingerprints, the way the dark patches you see, the dark lanes you can see in galaxy. Another thing, the next one is constellation Leo. You must I'm sure you know about all these 12 English constellation, Leo, Virgo and all that. So this is Leo constellation area, and at a particular site location in Leo, you will see this M65, M66 and NGC 368, which Messier could not see because of his instrument, but the later on people cited it and they gave the NGC number to it. And this Leo triplet is a wonderful view. Even in the 8-inch, I can see all of them in wide field eyepiece. But in a typical 8-inch, 10-inch also, in a good dark place, you should be able to see this trio or triplet, as it is called, Leo triplet. Next one, in 95, 96 and 106, again in constellation Leo. The next one, Sculptor, one of the biggest, largest galaxies, and a nice dust lanes you can see here, NGC 253, Sculptor galaxy. It's a massive galaxy. And if you want, if you are interested in the question answers, I'll be able to go to my Sky Safari Pro and give you additional details about this galaxy. The next one is Centaurus A. I've chosen this for you because the huge X-ray emission was found out when scientists pointed the X-rays towards this side. And later on, a black hole was discovered at the center of this galaxy. And now we know a lot about black holes and there's a lot of work happened. But I'm talking of way back in 1970-80 time area. I'll be able to tell you more exactly when it was done. That research was done. But a massive X-ray source in this galaxy. And that's why I've chosen for you. You don't see it in this shape. In 18-inch also, you don't see this separation that crazy. So this picture is slightly exaggerated, photographed in some nice telescope, but 8-inch, 12-inch will not show you this. 18-inch barely shows something close to this. Next one I've chosen is Sombrero Galaxy because it looks like a sombrero hat. And this galaxy is seen as a beautiful object with that sharp dust lane kind of a effect at its center, M104. Next one is Whale Galaxy. Again, a beautiful object if you have got a reasonably sized telescope, say 12-inch, 14-inch, 16-inch, or 18-inch, and a good sky conditions, you are able to see a whale-like shape and a satellite galaxy NGC 4627. This is 4631 and this is 4627. A wonderful view. The next one is a needle galaxy because this galaxy, its orientation is not facing us, or rather we see its side view, side face. So that's why you see it like a needle, and it's called NGC 4565 because you see it like a needle, the side shape. It's called needle in constellation Coma Berenices. And the last one, before I go to my last topic, is a set of galaxies. It's in the area Virgo-Leo boundary, and a person called, scientist called Markarian, he saw a long chain, and this chain is known as Markarian chain. It's a beautiful object for astrophotography. If you are interested, come to our astrophotography paid workshop. Kiran, myself, and Anurag are conducting it in the near future. And otherwise, go with your telescope to a dark side and go for this Markarian chain. And I'll guarantee you that you will not be able to locate it easily because this is the area where wherever you see there is a galaxy. म्हणजे मराठीत मी अनुरागला किरणला म्हणतो तिथे बघताना अरे पाहू तिथे गॅलेक्सी आहे, जिथे एम कराल तिथे या एरियात गॅलेक्सी दिसते. Around Markarian chain also, this region is full of galaxy because there is a whole Virgo cluster actually lying there. Very interesting stuff. Coming to my last area, comets, generally faint blobs. I use a site called Skyhound. So if you go to the Google and go for Skyhound, you will be able to go to the website called Skyhound, and they give all kind of details about comets, where the given comet is, which constellation it is, its day-by-day journey when a particular comet is close to Earth. You see this news in the Marathi English newspaper, so-and-so comet, it's a great time for astronomers. So all these people, I'm sure they are referring to Skyhound or something very similar website. And there are detailed views given. This comet will be visible at so-and-so time in this constellation near this sky and so on and so forth. Sometimes you see tail. So my astrophotography, 46P Vitanin comet, using my Orion 80A small instrument. The tracking drive is 4-nax drive. My camera was Canon M3 mirrorless, and I photographed it on 11 December 2018. This patch kind of a thing, fuzzy patch, is Comet 46P Vitanin. The next one is Comet Neowise. I photographed it from my daughter's camera. I was in USA, and this beautiful comet, which had tail, was seen, but it was monsoon year. All my friends were unlucky. I happened to visit my daughter. I got stuck because of COVID, first wave. And I was wondering, ye kab flight chalu hoga and all that. And then suddenly this comet was visible. And I thank God to getting me stuck in USA because I used my daughter's camera, Nikon Coolpix P600, just put it on tripod and photographed so many images, sent it to Anurag. Anurag stacked it for me and created this beautiful picture for me. So thanks, Anurag. The next one is Comet Leonard. Anurag and I visited a very dark space in the recent past, and Leonard was visiting Earth or the near Earth area. And then nice photograph he captured in his 5-inch f2.8 astrograph on his mid tracker and tripod and equatorial mount. And his camera is a Canon 600D. We both did this. Actually, he did it. I was accompanying him, but I helped him somewhere. 12 January 2022. Credit goes to Anurag. So what all you can do with all these objects? So there is a very interesting you can do, and Anurag and I have done it successfully. It's called Messier Marathon. Citing all Messier objects, 1 to 110 Messier objects in the sky in a single night. It's very tough. It's not easy. You have to plan. You have to study your telescope, how to use what to, which objects to point first. You don't go M1, then M2 and M3. No way. You have certain order which you have to a priori decide. If you are interested, contact any of us in Khagol Mandal. We have a lot of experts there and you will be able to get a lot of information. What is the time of the year to watch it? It's generally March 1st, 2nd, 3rd week, and you go for a dark night, which is moonless night. So this year it is March 1st week, moonless night. That's the best time when you can go for a Messier marathon run. If you are interested, contact any of our Khagol Mandal people, experts, and our people will be able to help you. So Anurag and I have completed a complete 110 Messier marathon. So our name is in the Hall of Fame in the ICDS site. Then we have tried some of the other stunts also. Go for all globular clusters, go for all open clusters in the sky. And the whole night we spent in the sky with 18-inch, running the marathon one after another. I think I have overshot by 10-15 minutes. Over to you for questions. So I'll cancel my presentation, stop share, and go for you for question answers.
Right. I think let's go one by one in the order in which people have put it in the chat. So I'll just call out the name and the person can unmute. So the first one is, let's see. Okay. First one is from Aparna. Aparna, you can unmute yourself and ask your question, but be brief. We have officially we have only 5 minutes to 8:30. Aparna, are you there?
I can read Aparna's question. Aparna,
Yeah,
if you are there, I'll just read your question for
she
everyone.
She doesn't
How
seem
to
to be there.
differentiate Venus and Sirius in the sky? Both are bright. That's correct. So the best thing is the sky map, because that will tell you the exact position. You feed the date and time, and you will be able to point. You will be able to look at which is Sirius and which is Venus. On a different note, different times of the year, Venus keeps changing its position. Sirius is exactly at the same right ascension declination where it is for years and years. So that's a way. Venus, look at me. You are probably Marathi. I don't know if you are Marathi,
No,
but Sirius, look, though it twinkles.
She's
Venus
not there,
doesn't
Ashirwad. I think she's dropped. So
let's go to the next one.
Yeah. So the next one is Atharva Sravant, I think.
Yeah.
What
What is
interstellar?
interstellar clouds? Interstellar clouds are clouds of gas, dust. Gas is generally hydrogen, helium, but could be some other things also, depending on how the cloud came up. If it is from the death of the some massive star, then it can contain some other elements also. But we'll go to astronomy, or I won't say theoretical, but deeper into astronomy. I'll just leave it with single line answer that they are gas and dust and a massive radius. They are few hundreds and thousands of light years in space also at times.
Okay. Next one is from Pranav Chandak. What do you guys
expect from JWST?
What is it
special? What is it special from other telescope? So it's like this. See, Hubble gave a lot of dividends in terms of pointing to very distant objects, and because of Earth atmospheric disturbances, which you see in even in 8-inch, 18-inch, and so on and so forth, which you don't see in Hubble because Hubble is out of our Earth atmosphere, and is able to point and send us beautiful pictures. Now, there is a limitation of Hubble. It's old and all that, the technology has gone ahead, that's different thing. But Hubble's primary instruments are concentrated on the visual spectrum. So whatever you see with the visual light, related to that. But very far distant galaxies, and you may have read, Atharva, I don't know, that the universe is expanding. And when there is a receding entity, there is something called a redshift. Just like the sound, there is a Doppler effect. I don't know in which whether you know about it. but just note it down. Otherwise, you contact us offline. We'll tell you. So remember two things: Doppler effect applicable to galaxies also. So there is a huge redshift because of Doppler shift, and these galaxies have such a huge redshift, which are very far, that they are away from red spectrum also. So red kya? They are gone in the infrared region. So there is a redshift, and red gaya, infrared mein chala gaya. It is away. So can Hubble see this? No. JWST can see it because JWST has all the equipment which are catering to infrared. So we see the universe is much distant than Hubble. That's a speciality, and for that, people have chosen a wonderful place in the sky called A2 Lagrangian point. Again, leave it out of this scope, but just remember these two things make it very special.
No, but so
And
he
it's
has
huge
asked
factor.
a follow-up question. Why is it at H2?
Later, not now.
All right. So then there is this question from Vaibhav Hatode. Why it is recommended to wear full sleeve shirts and trousers with shoes during observations?
Vaibhav, you go typically to dark sites which are close to forests or in the very jungle kind of area, or which are no man's area. You are away from the cities, you are away from the towns, you are away from the villages, and all kind of things, insects, snakes, scorpions, all kind of things you could experience. So it's a safety precaution. That's it.
Okay.
Okay, Atharva Sawant, I think is not there. So, sorry. What should I, Atharva again, what should I look for when I buy a telescope? I think that was covered in our last lecture, right?
See, Atharva, just in one line, not to disappoint you, the previous lecture is in Khagol Mandal's YouTube channel, you recorded, Shailesh Ansari. But in one line, see two things. First is its aperture and a very stable, steady tripod, or in a very cheap word, stand, mount. It should not shake. That's it. Two things. Much of the other things will sit right.
Next one is Swarangi Upasani. I think we are already on time, about time.
But it's okay.
Let's do 3 or 4 more minutes. So Swarangi Upasani, sir, what is exposure time?
Exposure time, astrophotography course. But in one line, how much time your shutter opens and sucks in the light as much. So I keep my mouth open and keep getting water inside. How much I can feel, that is exposure time in simple words.
Okay, thank you very much, sir.
So
Next one.
The next one is, sir, please share
your
cell
cell
number.
number.
I think why did you
We'll communicate through Khagol Mandal.
Right.
Just to be, because, but if you want to note down 7738649998, chalo.
All right, I think, yeah, we have more or less completed the questions. Now,
any quick one or two last questions, just as a respect to all the wonderful audience who had all the patience and love for me to come for the session. Any last one or two sessions, Kiran, please, 2 minutes.
In which galaxy there are ABCD stars, newborn stars?
Our own galaxy, Milky Way, but in the constellation Orion, you see this,
Yes.
and the object's name is M42.
Okay.
So remember M42 trapezium and do Google. That's it.
Okay, thank you.
So what is Magellan cloud?
Please.
What is Magellanic Cloud? I think that's the question the person is trying to ask.
Just repeat. What is?
I think she or he is asking about SMC and LMC.
Small Magellanic Clouds and large Magellanic Cloud. These are small galaxies all by themselves, and every huge galaxy, because of its gravitational structure, they keep some of these galaxies bound to each other. So the way in Andromeda you see this M32, M110, small and large Magellanic Clouds are our satellite galaxies. They are not the closest ones. There is a very faint galaxy which is much closer than us, closer than LMC and SMC to us. But you don't see that easily. LMC, SMC, you go to the southern hemisphere, you see them very easily. like a white patch.
Sir, is a Calistron Power Seeker 60 AZ okay for beginning?
Celestron, slow. Which one?
Calistron Power Seeker 60 AZ.
60 AZ. Uska, what is the aperture? They are saying, I don't know. Otherwise, contact me offline. Ashirwad@tillu@gmail.com. I'll tell you.
Okay, ma'am. Okay, sir. Thank you.
60
Sir,
mm,
you-
he says. 60
you said
mm is
some
good.
play-
It's a good starting
Play
point. Huh?
marathons.
It's not fine.
What is that?
Say again.
You said some time back, play marathons.
Okay.
What is that exactly?
So I'll tell you more. The name of the scientist is Messier, but actually it's spelled as Messier, Messier. Typical Marathi uchar. So Messier marathon. If you search that, you will get all the details. So Messier, way back when he was cataloging all the objects, in his name, people have, you can today see M1 Crab Nebula, M6 Lagoon, M20 Trifid, and so on and so forth, M42 Oran Nebula, up to M110, that wonderful galaxy in Andromeda. So all these M1 to M100 objects are named in a Messier catalog. Can you see them in January? No, because some of these objects are coming up with sun and setting up with sun. Can you see them in June, July? No, because it's monsoon. But if you go to some desert area or USA where there is no monsoon, still you can't see, because some objects are masked because of sunlight during the day. So no faida. In March, first week, second week, can you see all these objects? Yes, because sun is in such a constellation and none of these 110 objects are close to it. All 110 objects you have an opportunity in a single night to watch. Can you run in a single night with your telescope at a dark site and spot one after another? Yes, that's called Messier marathon.
Oh, that's fantastic.
Tough, huh? It's not simple.
All right, I think it's already 6 minutes.
Yeah, so we went for Grace question also. So Kiran, thanks so much. Anurag, thanks for supporting through all the logistics and so many other things. And people who came on the YouTube, thanks to them. Please don't forget to go to our site and get more information about our astrophotography workshop by Ashirwad, Anurag, Kiran and Ashirwad. It's a paid workshop, but lots and lots of information is being packed in 4 sessions and one special outing session where we'll give you a complete hands-on. You can bring your equipment also, and you will have a lot of takeaway of worth of knowledge. And it won't be recorded. It won't be available on our Khagol Mandal channel. It's a private session for those who pay for it, but guarantee you will have a wonderful takeaway. Go to our site and look for additional info.
All right, so thank you very much, all the participants. So as Ashirwad said, do go to our site, look at the astrophotography course. Also, next Wednesday again, we'll have next such lecture. Again, that information will be available on social media, our Facebook channel, our website. So thank you very much. Clear skies and good night.
Bye everyone, and thanks once again.
Thank you and good night.
Good night.
Thank you, sir.
Thank you, sir.
Thank you. Bye.